welcome everyone that's just joined. We'll make a start now. So this is our final Maths Week England 2020 webinar. We are joined today by Chandan Jha. He is a OR Society member. He's a senior research fellow in OR. He's actually joining us today from India because OR is a global field. And his research mainly focuses on efficiency and productivity evaluation. He works both on evaluating that in service economies and in education. He's worked in education, healthcare, banking, and the airline industry. So very varied career, hopefully lots of great advice in the Q&A. But for now, I'll hand over to Chandan and let him talk to you all about making decisions with maths and OR.
Yes, thank you, Eve. So, welcome all. So, this screen is visible, PPT screen?
Yeah.
Yeah. So, the topic of today's discussion, in this webinar, will discuss about decision making with maths and some applications of MCDM techniques. MCDM is a multiple criteria decision making methodology techniques. So let's start. Yes. So let's start with this statement. I quoted from HBR, the Harvard Business Review article by Peter Drucker. An effective executive makes the decisions as a systematic process with clearly defined elements and in a distinct sequence of steps. So this is something reflecting how important the decision-making process for managers or for decision makers. Fine. So in other words, we can see this process, this entire decision-making process is highly essential to solve business problems or real life problems, which includes sometimes single criteria or most of the time many criteria, or we can say multiple criteria. It may be tangibles or intangibles. Also, if we see closely the industrial problems, business problems, which involves multidisciplinary knowledge, which includes the technical aspects, economical aspects, environmental aspects, and social aspects. Apart from that, politics and regulations, the government rules and regulations are also the factors which can impact all these problems in policy makings and in other decisions. So basically, this multi-criteria decision making is the part of operations research, and it supports the decision maker to resolve problems when lot of criteria like conflicting criteria, for example, price versus quality. So this is just one example, or price versus quality versus some other specifications. So like conflicting criterias are there, so it helps to resolve them. And this is a practical and powerful tool which facilitates the incorporation of quantitative as well as qualitative factors, such as the experience or how to measure the service quality. So like that. So qualitative factors which may impact highly and influence the decision making, the entire decision making process. So we can use both quantitative as well as qualitative factors. If we see the applications, so this is highly used in policy making, group decision making process, and if the situation is very difficult, very complex situations, basically if we are looking for the ranking or prioritization to identify the most to least desirable alternatives. So let's say we have 4 or 5 alternatives, or we can say sometimes feasible solutions for a particular problem. But that solution is feasible, that is not necessary that that will optimal. So basically selecting the best solution, selecting the optimal solution within the set of some alternatives. So selecting the most desirable to least desirable alternatives, having the preference order, having the ranking orders. So the choices where the decision makers will make based on some methodology. That methodology comes under the MCDM, multiple criteria decision making methods. So we can see the applications in managing resources, the industrial projects in healthcare sector, education sector, logistics, energy sector, and also in technology choice, research and development, priority settings, facility locations in healthcare and in logistics, and in benchmarking also comparing the performance of one firm to other firms, and quality management and other strategic planning issues. So what are the general steps of MCDM? How we are going to evaluate how the researcher or a decision maker or a manager is using these MCDM techniques. So first is structuring a decision problem. So one thing is very important, the role of decision maker. Who will take the decision, whether it's a general person, common people, or it's a government, or maybe an organization, or a group of managers, the top management, the senior management, top management, or middle level managers. So who will take the decision? Because in this process, the role of expertise, judgments, the weightage assigned for a particular criteria, alternatives is very crucial and critical. So that's very important. So first thing is who will take the decision? Who is the decision maker? Then define the goal. What is our goal, whether it is cost maximization or profit, cost minimization or profit maximization, or selecting the best optimal solution within the feasible one, or we need to rank the priorities. So we have some set of alternatives, and among those alternatives, which is the best one? So the choices and rankings to our preferences. So basically the determining the criteria for evaluating the consequences of each alternatives, because we need to assign the weight for available criteria. And so these two things, weight assign and ranking process, is very crucial in this technique. So we need to assign the weight to each criteria, and then after that we need to follow some steps, some algorithms to calculate the feasible alternatives, to calculate the best alternatives based on the ranking preferences. There are lot of methods like AHP, TOPSIS, we'll discuss later. But if required, this is very important, when we are recommending any kind of suggestion or solution to maybe to government or in policy making, so we need to see if that is essential, then go for further evaluation. So consistency checking and re-evaluation kind of thing, and what if analysis, scenario analysis, so that kind of thing. So considering different situations, so like pessimistic, most likely, and optimistic kind of scenario. So whenever recommending final whenever giving the final recommendation, if required, if the issue or problem is highly sensitive for the public in case of government policy, so then we need to do the final or further evaluation, just like what if or scenario kind of analysis. So if we see the popular MCDM methods, so one is AHP. So basically, what is this and other methods like these are very popular one. So second one is the technique for order of preference by similarity to ideal solution, basically known as TOPSIS. Third one is data envelopment analysis, so DEA, and hybrid MCDM. Hybrid MCDM represents in this techniques or process we will not use a particular or a specific techniques. We will use the combination of, like for example, AHP and TOPSIS, or TOPSIS or DEA, or AHP and DEA. So we will use the combination of these techniques. So AHP along with DEA or TOPSIS along with DEA. So mix kind of using multiple MCDM methods, and sometimes extending the algorithms. So one algorithm is there, let's say for TOPSIS or AHP, then see where is the variations. So then if it is possible or feasible to extend those algorithms uh, with the help of literature, scientific literature. If that is possible, then definitely one should extend the algorithm to find a better result or to see the better insights if possible. So these are a few popular MCDM techniques. So I already discussed AHP, TOPSIS, DEA, and MCDM. So if you see the real life or business applications, very basic one, I will not discuss the very highly complex kind of things. So if you see the basic applications, so one is, it's a very basic example, selection of car or automobile. So look, the criteria, the conflicting criteria I discussed, so one is price and quality. So there is a conflicting criteria. These criteria are conflicting in nature. So if we increase the price, definitely the quality will increase. But if we decrease the price, the quality will also decrease sometimes, most of the times. So how to manage all these criteria in one go? So if there are multiple, so this is just basic example. So similarly, selection of university. Now it's very interesting. So look, one thing is outcomes of a university related to graduations or graduation outcomes, which includes the degree, the graduates, academics, and faculty members. And other thing is outcomes related to research and development. So that includes the publications and research works. The third is your professional practice, which includes the sponsored project or income from the revenue generates from the sponsored projects or consultancy works, or maybe consultancy for government or some other private industry, or some public sector. So there are a lot of things which can impact during the selection process and during the evaluation process of the academic institution, because graduation outcomes are different, research outcomes are different, professional practices, the executive programs, the consulting projects, these are the different from the graduation outcomes. So if we have multiple criteria, then how to use all those criteria in a one algorithm or in a one methodology to solve or to select the best alternative, to select the best one. Another interesting example, let's let's say evaluation of a contractor for a particular project. Let's say we have contractor A, contractor B, contractor C, contractor D, and contractor E. So we have 5 alternatives available. But here the criteria we can use, as I discussed, we can use both quantitative as well as qualitative factors. So one is your financial criteria, other is the non-financial criteria. So we'll use both, we'll discuss both. So let's see, like one is experience of a contractor, within an organization, whether the handling the similar kind of projects or the different projects, but having the similar kind of work experience. Then financial stability is one thing, then quality performance, manpower resources, equipment resources, and current workload of that particular contractor within the organization. So if this is the situation, if this is the condition and we have 5 alternatives, then how to select the best one? Because we are not here discussing only financial measures. That is something different. We are also seeing the non-financial part, which is qualitative, sometimes like experience, or the quality performance, which is something different. Then the efficiency and productivity evaluations using DEA, or sometimes ranking using TOPSIS and AHP in various sectors like education, healthcare, airlines, banking, railways, and other logistic firms. So this is highly means if you see the practical applications or the examples, real life examples, business applications, so very highly used in the practice. So let's understand. So here I discussed 3, and if I consider hybrid MCDM, then application of 4. But I will discuss here only AHP. It's a basic, so and the basic one, the algorithm. So this is basically the process in which we are calculating the relative importance of each of several conflicting criteria which is being used in the decision making process. And as I discussed earlier, the beauty of this algorithm is we can incorporate the qualitative measures as well as quantitative measures during the evaluation. So the main thing is we need to, what this algorithm, the AHP algorithm says, basically one thing is set your goal and who is the decision maker, who will take the decision, because based on their judgment, based on their experience, they will compare the criteria and assign the weight. So first is determine the relative weights of the decision criteria on which we are going to take the decisions. And other important thing is determine the relative rankings. So priority of the alternatives, basically the priority of the preferences. So the most desirable to the least desirable. And in this, we will take both qualitative as well as quantitative information. So during the judgment in the decision making process. So simple example, as I discussed here, like evaluation of a contractor for a particular project using experience, financial stability, quality performance, manpower resources, equipment resources, and current workload. So this is something a bit complex as compared to this one. So I will discuss this. This is very basic. So let's start. Like problem is selection of a car and we have 3 alternatives. So car X, car Y, car Z. So basically car X, car Y, car Z, you can assume any 3 brands, or within a brand 3 different cars are there. So I have not given any a specific name to this in this problem. So just I labeled car X, car Y, and car Z. Yes. Fine. Then we have 4 criteria. So based on these 4 criteria, one is price factor, MPG factor, mileage, comfort, and style, how it looks. So basically on these 4 criteria, we are going to evaluate, I will use the AHP method to understand or to solve this problem. So we have 3 alternatives. Alternatives are car X, car Y, and car Z, and we have 4 criteria. So first criteria is price, second is MPG, mileage, third is comfort, fourth is style. Yes. So as I discussed earlier, what will be the step one? Step one will be the what is our overall goal? Select the best alternative. What are our criteria? Decision alternatives. So we will focus on that. Then we will try to develop a pairwise comparison matrix, and will try to rate the relative importance between each pair of decision criteria and alternatives. Here comes the role of expertise or the role of experience of a decision maker. Sometimes the decision maker who is going to take the decision on this particular problem or situation, they can uh, rate the relative importance within the criteria for different criteria based on their judgments or experience, or sometimes they can take help from the experts help, or with the help of some other experts they can assign the weight, because this is something where we need to compare one criteria to other criteria and assign the weight values, the relative importance, like we just try to understand in this table. So like the right hand side is numerical rating, and the left hand side of this table uh, represents the uh, how we are going to set our values for uh, preferred values. So one here is equally preferred. So if both the criteria is equally preferred, the decision maker will assign the value 1. But if one criteria is extremely preferred over another criteria, then they will assign the value of 9. That is the highest one. However, the values, like we can see, values are 1, 3, 5, 7, 9. So 7 is a bit lower value than the from the extremely preferred. So extremely preferred is 9, very strongly preferred is 7, then a strongly preferred is 5, moderately preferred is 3, and equally preferred is 1. And also if in case of compromise or some adjustment, we can also assign the value, or decision maker can assign the values like 2, 4, 6, 8, and sometimes reciprocal values, because if you compare price versus quality, so if quality is 2 times more important than price, so the value you have assigned 1 and 2, so price as compared to quality you have assigned 2 for quality. So quality with respect to price will be 1 by 2. So that's the logic. Fine. We'll try to understand this with a numerical problem in Excel. So in theory, just focus on that. So this is how you are going to assign the numerical ratings for one criteria and comparing uh, criteria one criteria to another criteria. Fine. Third is in further steps we will normalize that matrix. So let's say we have 4 criteria, so the matrix will be 4 cross 4, 4 into 4 cross. So 4 cross 4 matrix will be there, 4 rows and 4 columns. So we will compare each criteria with each other, and then we will try to normalize that initial matrix. So how we will normalize? We will divide each element of that matrix with their respective column sum. So we'll see in the Excel how we will use that. And then we will try to calculate the priority vector. This is where comes the role of consistency and whether we have assigned weight are correct or not. So after developing the priority vector, we will see the consistency. This is required because sometimes it will reflect whether the assigned weight by the decision maker is correct, was correct or not. So there are some steps, algorithms in these methods, which will show whether the assigned weight by the decision makers are correct or not. So that values we will check with the consistency ratio. So this step, consistency, check for consistency, includes three things: consistency index, which we will see how we are going to calculate. Second is random index, which you can see here, random index RI. This is something which the researcher Sati in 1980 developed while using lot of simulation experiments, and for a set of alternatives, where let's say n is the number of alternatives. So for, if we have four alternatives, five alternatives, or eight alternatives, sometimes 10 alternatives, so based on the value of n, there is a specific random index value which they derived from lot of experiment, research and simulations. So that value they will use directly in the algorithms. However, the consistency ratio CR is the value which is consistency ratio equals consistency index divided by random index. So CI by CR. So in next, I have discussed here. So three things are there: consistency index, random index, and consistency ratio. So what I discussed earlier, consistency index is this lambda max minus n divided by n minus 1, where n is the number of criteria and ratio is Ci by Ri. So basically, if we see the practical implications in practice, the value of CR, if that is 0.1 or below 0.1, that is considered acceptable value. But if that is not the case, then the decision maker needs the further evaluation or re-evaluation the entire process. Fine. So this is very crucial and critical to check the consistency of the process of the steps, whether we have assigned correct weight or not. So the CI reflects the consistency of one's judgment, the decision maker's judgment, and RI is the average value of CI for random matrices. This is the reference Sati 1980. In this research paper, they have discussed a lot about this. So let me share the Excel file. Yes, I think this is visible. Yes. So what was the problem? So we have four criteria: price, MPG, comfort, style. So let's understand in a very simple and basic way. So the value 1 and here the value 3 and 2. So this is just an example. Fine. This is just an example, and for illustration purpose, I have tried to follow the steps and derive the results, the final results. So the decision maker can use another rating, or they can assign another value based on their preferences, based on their compare rating factors. So let's try to understand with this example. Fine. So if we change the relative importance or assign weight values, then definitely the result will change. That is the another things of discussion, but let's try to focus on this. So this value 1, so look, price versus price 1. So if criteria is being compared by themselves, so MPG versus MPG 1, comfort versus comfort 1, because we are comparing with themselves. We are comparing with price versus price. That's why this is 1. But price versus comfort 2, here the value 2 represents, we are going to give the importance of price 2 times as compared to comfort. So if price, here the value 2, in this column, third column, first element. So comfort versus price will be 1 by 2. Why? Because the reciprocal of that value. Similarly, if this price versus MPG is like price is 3 times more important than MPG based on the decision maker's judgment, then the MPG as compared to price will be 1 by 3. It's very simple. So based on the decision maker's experience or judgments, their own kind of important factors, which factors they also look at. Style is so price is 2 times more important than a style, so I have assigned value 2. So a style as compared to price is 1 by 2. So this is just the basic initial matrix. So 4 cross 4. Fine. Then how we have normalized this matrix, because what was the second steps? Normalization of the initial decision matrix. So look, this value 0.43, how I got this value? So basically this value, the first one, the first element, the first row and first column, first element divided by the sum of this their respective column. So first column. So B3, so this is Excel formula, B3 divided by sum of B3 to B6. So basically the summation of all the column values. Fine. So this is how we have normalized. So if we see the other calculations, the same thing for this third element, the D3 divided by sum of their respective columns. So 2 plus 0.25 plus 1 plus 2. So yes, so this is the normalized matrix. Then further step, what was that? To compute the priority vector. This is very important. So in this we have what we did, all the values, these values, the normalized values, we have taken the average of all these values. So this is the priority vector for this matrix. And what was the matrix? Matrix for the criteria. So pairwise comparison matrix for 4 criteria. What was the 4 criteria? Price, MPG, comfort, and style. So this was the process for this matrix. Similarly, after that, first thing what we did, we have compared each criteria with each other and developed a matrix, then normalized that matrix, and then we have calculated the priority vector. Further, we will compare each brand like car X, car Y, car Z. So I relabel like brand A, brand B, brand C. So like so we will compare all these alternatives. So basically this is the available alternatives: brand A, brand B, brand C, that represents the car X, car Y, and car Z. So basically we have 3 alternatives, and all these 3 alternatives is now being compared with each criteria separately. So pairwise comparison amongst car on price. So again, we need to assign the relative importance for each of these available alternatives and follow the same process: normalized matrix, then priority vector. So the same calculations I have shown here. The element, the first element divided by summation of their respective columns. So this value 0.14, the value 0.33 divided by summation of their respective column. So this is the initial decision matrix, this is the normalized one, and this is the priority vector. So relative importance of the each criteria, and for available alternatives we have the matrix, initial decision matrix, then normalized, then priority vector. In the last steps, what I discussed was the check for consistency. So this is very critical and highly essential, required. So how we will check for the consistency? For that, we need to use the function which is there in the Excel. So basically what we are doing, we are multiplying the two matrices. So this is matrix multiplication. The two matrix, one is initial, the pairwise comparison matrix, which is this one, the initial matrix, the price, MPG, comfort, style. So initial matrix, initial decision matrix for alternatives. Then second is the PV, this priority vector value. So this matrix. So basically we are trying to multiply two matrices, and this value, if you see, is the M mult here represents the matrix multiplication, and this is B3 to E6. If you see, B3 to E6 is the initial matrix, and this one, this is the priority vector values. So look here, priority vector values is there. So basically we are using this function to get these values, and this is essential because after that we will calculate the principal eigenvalue. So that is also known as lambda max. So if you remembered in PPT, the formula for consistency index was lambda max minus n divided by n minus 1. So this is required to calculate the consistency index. So how we will calculate this? T3 is the lambda max in this situation, in this case. So lambda max minus n. N is the number of alternatives. So here n is equal to 4 because we have 4 alternatives, not alternatives, the criteria. So in this case, this is criteria. In this case, this is number of alternatives. So we are discussing this one here. So in this situation, the number of alternatives, not alternatives, criteria is 4. So n is equal to 4. Fine. So this is the value 4. So lambda max minus n divided by n minus 1. So simply we have used the formula, and random index, that value is given in the PPT file for several alternatives or criteria, that is derived from the experimental research. So a lot of simulation and experiments they did, and they have defined some specific values. So for n is equal to 4, this is the value. So the link, the references I have given there, SETI 1980 in that paper, or this is available in a public domain because this is from the research. So for n is equal to 4, this is the value. Then consistency ratio. What was the consistency ratio formula? CI by RI. Consistency index by random index. And what is this value? 0.07. So does it require further evaluation? Not. Why? Because the value is less than 0.1. So if value is less than 0.1, that is perfectly fine. So the same steps we did for entire process. So in this situation, first we have compared each criteria with themselves and with one another. Then we have compared each alternatives, like pairwise comparison among cars on price, pairwise comparison among cars on MPG, then for comfort, then for style. And this is what we got, the consistency ratio value. This is 0.07, then this is 0.02, this is 5.05 and 0.03. So since entire process seems perfectly fine, then what we will do in the final step, in the final recommendation, the values we got here, the PV values, priority vector values, this one 0.40, 0.09, 0.22, this is the final relative importance during what we have calculated while following these steps. So what we will do, all these values, so this is for the criteria. So that's why I have set it in this green color. And these are the PV values, which is for the different alternatives like brand A, brand B, brand C. So we have three different alternatives, and we have compared these three different alternatives with each criteria separately. So definitely we will get these four uh, values matrices in this color. So in yellow color we can see this values for comparing different alternatives for price, then for MPG, then for comfort, and finally for the style. Yes, and we will multiply all these matrices. So this yellow one and this green one. So for price, MPG, comfort, and style, and this is the PV values for four criteria, and this is your final recommendation. So this is simply the mmulti function we have used. I have used. So matrix multiplication, this function is there in the Excel. And while using this matrix multiplication, this is the final value. So as you can see, what is the recommendation? The best choice is the second one. So whether you say the brand B or car Y, because earlier we have car X, car Y, and car Z. So three alternatives was there. So among those three alternatives, the middle one, the best choice is, or whether say brand B or car Y is the best. You can, means I have not specified any name, whether that is BMW or Mercedes or some other thing. So just a level those things. This is just for the purpose of numerical examples to explain how this AHP things works in the MCDM techniques context. So in this situation, while considering all these values, this is the final recommendation. The best choice and the pairwise comparison matrices are consistent because the values of CR is less than 0.1 in all the cases. So this second one is the best choice. Fine. So yes. Further, if we see the if further anyone would like to read more about MCDM techniques or methodology, so definitely they can means study more, and there are a lot of references, research articles, papers, scientific research papers. So basically what I discussed just now is the application of mathematical methods or applications, and this is how OR is helping to take better decisions. So the example I discussed was the very basic one, but it is highly effective in when the conflicting criterias and a lot of conflicting criterias, multiple criterias are there, and we have n number of alternatives, and within those alternatives we need to select only one, the best one, or we need to see the preferences, the most desirable to the least desirable alternatives. So then that methods, MCDM techniques, methodology is highly useful. So this is used basically not only MCDM. Here I am discussing the operation research, the entire operation research, when the decision is complex, unclear, and we need to see the feasible solutions, optimal solutions. Sometimes we have only single objective, or sometimes we have a problem to solve multiple objective optimization. The techniques using simulation, optimization, and mathematical models, sometimes extending the algorithms. And this is where the career opportunities. And yes, so basically it requires the knowledge of maths and programming. Then this is where you can search more and find more details. Yes, thank you for, and also I would like to thank the OR Society, Operation Research Society, for giving me this opportunity to present this work or idea with the students. So in Maths Week England, so the objective was to explain some mathematical techniques, some MCDM techniques using mathematical methods to solve the practical problems, real life problems. So thank you.
Thank you very much. That was really interesting. So if any of our participants have got any questions, please do put them in the chat or in the Q&A. We're very happy to answer all of your questions. And just to give you one to get started, while everyone else thinks of them, what sort of projects have you used MCDM on recently? Like what kind of companies have you helped with this technique? Or what research have you done into it?
Yeah, it is highly applicable in, I think, in every sector. Like you can see, healthcare sector, education sector, and if you see the applications within a particular domain of subject knowledge, like supply chain management, project management. Like I have discussed the selection of contractor for a particular project, whether selecting facility locations. So invest management in resource allocation and resource management, and finding the priority or ranking our preferences for a particular uh, problem, like selection of supplier, who is the best supplier in supply chain management, then the ranking the transportation, logistics, and even in energy management we can see invest management, where to means how to select the facilities to, like managing the waste and waste disposal. So like that. So if you have multiple things to decide, then how to select the best one. For example, I have given to select how to select the academic institutions, or sometimes we have some cost criteria, we have some benefit criteria. So so cost criteria is something different, benefit criteria is something different. So cost, one thing is cost benefit analysis, and other thing is seeing the where a firm is standing. So in benchmarking and strategic planning, these MCDM techniques, operation research techniques is being used to, if you use data envelopment analysis, so then seeing the efficiency, calculating the efficiency of a particular decision making units, whether that is operating on an efficient frontier or not. So it requires a lot of study, knowledge, and effort to understand the operation research methods and methodology. And if you see the applications everywhere, I will say everywhere, in airline industry, healthcare, banking, everywhere, whether that is the problem of cost minimization or revenue maximization, profit maximization, enhancing the customer satisfaction, the customer values. So everywhere it is being used. Yes.
Cool. And this is something that I've asked the other people who've done a webinar as well, and it's interesting getting different opinions and views on this. What advice do you wish that you'd perhaps had when you were younger or just getting into operational research? Is there anything that you wish you'd known sooner?
Yeah, it requires basically the knowledge of like good mathematical knowledge. And if that interest is there, then definitely he or she should choose the career in OR. And in our society also, Operation Research Society, they can join as a student member. They can explore the various opportunities. They should attend the conferences, the other events, the workshops, the similar kind of webinars. So definitely those things will enhance their experience, and they will know more and more about operation research in detail.
I like that answer. Yeah. Anyone over 16 can join the OR Society for free as a student member. So I think that's good advice.
Yes, yes. This is we are serving the society for the students, for the benefit of students, for the benefit of knowledge community, for the benefit of researchers, students, upcoming researchers. So definitely the society, this Operation Research Society will have a lot of options for the newer students, the younger students, and they can join the events to explore more, having more experience in different events. So yes, that interaction will help them a lot.
Certainly hope so. And aside from the help we can give students in terms of like information about universities or careers in operational research, we've also got a lot of resources available for teachers. So if there are any teachers listening,
Yes,
we
yes.
can come into schools and run workshops, or we can do them remotely, or you can just download our resources and have a look yourself. So I'd recommend having a look at those if you'd like to learn a bit more.
Yes, yes, so as Eve said, we have different resources for students and teachers, and also the different events like webinars, workshops, conferences, career fairs, and other events. So those kind of events and interactions and experiences from those events will enhance their uh, much more experience in future. Yes.
Okay, well, the question and answer and the chat are very quiet at the moment, so I assume that you've done a brilliant job preempting everyone's questions and answering them in your talk.
Thank you.
I'll ask you one more question and then I think we'll wrap up and let everyone go and grab a cup of tea before they go to their next lesson or webinar, whatever it may be. What do you enjoy the most about working in operational research?
We are solving problems, the real life problems, business problems, whether that is calculating the efficiency or productivity of a particular firm or group of firms, or sometimes at institutional level, sometimes at a state level, sometimes for entire country, or sometimes while comparing the performance of across countries like US versus UK or US versus China. So how the logistic firms are performing, how the airline industry is performing. And this is all about solving the business problem. So it's very challenging, and if it requires a lot of knowledge and effort to apply all those concepts, methodologies. So it's very challenging, but yes, it's interesting.
Awesome. Well, thank you very much for your time this afternoon. Really appreciate you joining us and giving this webinar. I hope everyone's
Thank you.
enjoyed it. I know I found it interesting.
Thank you very much.